I'm Kim Ogden. I'm a professor of chemical and environmental engineering at the University of Arizona. My area of research is bioreactor design. I do anything from pharmaceutical bioreactors to production of algae to make biofuels such as jet fuel or biodiesel. I would like to thank the Vinci Circle for the fellowship and the funding. I'm going to use the funding to replace some older equipment in my laboratory, more specifically my autoclave that I use for sterilizing media and glassware. This is our arid raceway system. It is a system designed by a couple of my colleagues that allows for efficient production of algae. What you have is a serpentine pathway here for algae to flow, and all up in this area, the basin area, is where photosynthesis occurs. So the algae will photosynthesize and grow during the day. At nighttime, what happens is these airbags go down and all of the algae is moved into the canal for the nighttime. What this allows for is in the evening, the algae can be in the canal where respiration will occur and no photosynthesis, and we do not lose as much heat to the atmosphere at night. Also, what happens then and in the morning is that the sun comes up and we hit the solar panels. The solar panels heat up and the pumps come on in the morning and start the production of algae and growth during the day once again. From the raceway, this is where we harvest. The algae and water will come in here in this darker green pipe, and then the algae and water are separated in the centrifuge, and the water comes back here and is pumped back to the raceway so that we can recycle and reuse our water. Over here is where the separation occurs. You're separating the water from the algae paste in this centrifuge. It works in a spinning motion, and the algae gets stuck inside here and the water is pumped back. The algae example of it is here. It's kind of a oily type paste that can be converted into fuel. When we are done, what we end up with is like a bag of algae here. And as I said before, this can be converted into jet fuel or biodiesel. Another thing that you can do with it is you can form it into dry pellets. And these dry pellets can be used for fish feed or oyster feed or any other type of feed that you would like.
My name is Manuel Vasquez. I go by Manny. I am a chemical engineering major, currently in my junior year. Currently my project is testing whether a batch or fed batch system works better to scale up algae. Dr. Ogden has been fantastic. When I first came in, I didn't know anything about research. I started this lab as a freshman. I finished my freshman year, started the summer of that freshman year, and I had no idea, didn't really know what research was. And she took me in and she said, okay, first we're gonna have you work with a graduate student. You're gonna assist him and you're gonna learn the fundamentals, and that's what happened. And after he was off, I had more experience and I felt more confident. So she pushed me to take on my own project. And then from there, that's what I've been working on.
I invite you at any time to come into our facilities if you'd like. You can learn more about production of algae to make biofuels and feed. The site is at Roger and Campbell, and we could schedule a time for you to tour it.